Hello friends, in this session we will discuss about conductometric titrations. Here we measure the conductivity of a solution during the process of titration and plot a graph of conductivity against volume. The endpoint is determined as a point of intersection between two linear portions of the curve. Let us consider a strong acid, strong base titration. For example, titration of sodium hydroxide against hydrochloric acid. A fixed volume of hydrochloric acid is generally taken in a beaker and titrated against a solution of sodium hydroxide. Hydrochloric acid, being a strong acid, dissociates almost completely to give H plus and Cl minus ion. On adding sodium hydroxide, a reaction takes place to generate water and NaCl. NaCl, being a salt, dissociates to give Na plus and Cl minus ion. Water, being a weak acid, remains almost unionized. In other words, as reaction proceeds, mobile H plus ions are being replaced by slow-moving Na plus ions. As electrical conductivity depends upon the number and mobility of ions, conductivity decreases gradually. This can be seen from the graph. As you can see, in the first portion of the graph, there is a downward slope. This region represents the decrease in conductivity. The conductivity value continues to decrease till the endpoint is reached. After the endpoint, on further addition of NaOH, conductivity begins to rise. This is because of the increase in the number of fast-moving OH minus ion. Endpoint is measured graphically as the point of intersection of the linear portion of the curve. In the case of weak acid strong base titration, for example, the titration of sodium hydroxide against acetic acid, NaOH is added gradually to acetic acid taken in a beaker. Acetic acid, being a weak acid, undergoes only limited ionization. As a result, conductivity of the solution is initially low. On addition of NaOH, the reaction proceeds to form sodium acetate and water. Sodium acetate is highly ionized and dissociates to form Na plus ion, and conductivity gradually increases. Once endpoint is reached and all the acetic acid has been utilized, further addition of NaOH leads to the formation of fast-moving OH minus ion, thus dramatically increasing the conductivity, as can be seen from this graph. The endpoint is determined graphically as the point of intersection of the linear portion of the curve. In the case of strong acid weak base titration, for example, the titration of ammonium hydroxide against hydrochloric acid, the titration proceeds by gradual addition of ammonium hydroxide to fixed volume of hydrochloric acid. Conductivity is initially high as hydrochloric acid, being a strong acid, dissociates completely to give H plus and Cl minus ion. As reaction proceeds, hydrochloric acid is consumed and ammonium chloride formed, which dissociates to give slow-moving ammonium ion. Thus, conductivity decreases as the reaction progresses. Once the acid is completely neutralized, the conductivity does not vary significantly as ammonium hydroxide, being a weak base, is only weakly dissociated. The point of intersection of the two linear equations of the curve gives the endpoint. Let us look at the very interesting case of weak acid, weak base titration. The conductivity of acetic acid is low as it is a weak acid. On initial addition of ammonium hydroxide, a slight decrease in conductivity is observed. This is because the ammonium acetate formed dissociates to give acetate and ammonium ion. They suppress the dissociation of acetic acid and ammonium hydroxide due to common ion effect. However, as reaction proceeds, more and more of the ionized salt is formed, thus increasing conductivity. This rise in conductivity continues till the endpoint is reached, after which it does not vary significantly because of the low dissociation of ammonium hydroxide. The endpoint is determined graphically and is a point of intersection of the linear portion of the curve. Conductivity measurements are also useful in the case of precipitation titration, where visual detection of endpoint is difficult because of the formation of the precipitate. As in the case of titration of potassium chloride against a silver nitrate, silver chloride is formed as a precipitate. In this reaction, as the reaction proceeds, chloride ion are replaced by nitrate ion, both of which are of nearly the same mobility. As a result, conductance remains unchanged till the end of the reaction. Once the reaction is complete, further addition of silver nitrate leads to increase in the concentration of Ag plus and NO3 minus ion, thus increasing the conductivity. Endpoint is determined graphically as the point of intersection of the linear portion of the curve. We shall conclude this session by discussing the advantages of conductometric titration. The first advantage is that it can be used for the titration of colored solution even when a suitable indicator is not present. It can also be used for titration of very dilute solution and the results are obtained at reasonable accuracy. It is suitable for titration of weak acid, weak bases, and also for precipitation titration. The graphical method employed reduces error, especially those which arises due to incorrect determination of the color change at the endpoint. Thank you.